All right, so we're back at it again today. Now, good news about our lesson today is there's really no new mechanics, all right, to teach you. We're going to do something called solving by graphing, which means you just need to know how to graph our quadratics, which we spent the last couple of lessons reviewing and working on. So, to get us into the work for today, we have two warm-up problems there. So I would like you to go ahead and pause the video, all right, and graph those first two quadratics there, and then turn the video back on and we'll see what you remembered. All right. I'm sure you remembered everything, right? It's fresh. All right. It's all you dream about. It's all you think about. You can just see those, all right, quadratics in your mind, just like rainbows, right? Popping up. Beautiful, beautiful, beautiful. It's not quite Deadpool on a unicorn in front of a rainbow, but they're beautiful all on their own, right? All right. So let's look at our two warm up problems here. So we can see that we have the first one in vertex form, the second one in standard form. So I'm going to just flip to where I have these worked. All right, so we can go through them. So when we look at our first one, there's very little like pre-work involved, right? You can look here and see that our vertex is -1, -8. So I'm going to start there. Our a value is 2, and then 3a would be 6. So I'm going to go up 2 to the right one, up 2 to the left one. And then I'm going to go up 6 to the right one, up 6 to the left one. Hopefully you guys are drawing better quadratics than I am. All right, haven't made it through my second cup of coffee yet, so maybe my hand's just a little bit nervous. I'm gonna blame it on the software. But so we move to problem 2. Now this is what the entire last lesson was focused on was, okay, so how do I graph something in standard form? Well, this is where we have to do a little bit more work. So remember, we have to do -b over 2a. All right, so in this case, b is 4. All right, so the opposite of 4 would be -4. A is -1. So 2 times -1, -4 divided by -2 is 2. If we go back and plug that into our equation, we should get 9. So our vertex is 2, 9. Now my a value is -1. So I'm going to go down one to the right one, down one to the left one. Then I'm going to do 3a, which is down 3. Now I went ahead and had room, so I went ahead and did 5a, which is down 5 to the right one, down 5 to the left one. Now the reason why I did that, all right? So today's lesson is solving quadratics. Now what that means is we're looking for the x-intercepts. We're looking for where that quadratic graphs or excuse me, the quadratic graph crosses the x-axis, right? So this horizontal axis is the x-axis, right? So we're looking for where does it cross the x-axis, all right? And you can see what happens with both of these graphs is that they cross twice. That means there are two solutions. Now, from all of our work solving, that should not surprise us because we know when we've solved quadratic equations this year, all right, that we get two solutions sometimes. And this is what those two things are representing, all right, how many times it crosses or intersects the x-axis. So when we go back to our notes, right, it asks us what are the intercepts for the two graphs above, right? So when I'm looking at this, I can see that one x-intercept, all right, is -3, 0. All right. And my other intercept is 1, 0. All right. And then for this particular problem, I can see that one intercept is -1, 0. All right. And 5, 0. All right. So there are my two x-intercepts. Those are my two solutions. All right. And if I were to, and you guys might remember this, if I were to put the 0 in for y, all right, okay, oh my goodness, why is it still writing? Oh no, it's out of control. Oh, stop, stop. Oh my goodness, what is happening with this thing? It is just, let's see if I can just hit undo. Hit undo. Come on. Oh, thank goodness. All right, it got out of control. So what I was about to say is if we put 0 in for y, because we know if it's an x-intercept, it's on the x-axis. So y is 0. So I would have 0 equals. Maybe it'll do this time. So 0 equals. All right, and we'd have 2. So slow all of a sudden. X plus 1 squared. All right, minus 8. So we've solved equations like this before this year. And if I were to go through our solving process, guess what two solutions we would get? -3 and 1. Now it's just a visual guide to that. All right, so let's jump back to our notes on the first page here. All right, and so when we think about what we're doing today, all right, we're solving by graphing. Now, there are some limitations to graphing. We'll talk about a little bit of what those are as we move through here. All right, and this is kind of where I was getting to, right? So whenever a quadratic equation is set to 0, all right, you can see that I put 0 for y here. I put 0 in for y here, which is what I was trying to do before my pen went crazy. All right, we are solving these, right? And we could do this algebraically. And in fact, we've done this one algebraically this year. We're going to talk about this, how to do this algebraically in a couple lessons. We're going to use something called the quadratic formula. I keep saying that, don't I? All right, so now what we're looking for are the x-intercepts. Now, we've mentioned this before, right? Those are also called solutions, right? So you might see the word solutions, all right? You might see the word roots, right? All right, and so we're all talking about kind of the same idea, all right, about, all right, when you see these words, right? All right, so there you go. All right, now, when we think about our graphs, when we're looking for these x-intercepts, we have 3 different possibilities, right? And we saw this possibility in our warm-up, right? Graph could open up, could open down, and we could have 2 solutions that cross us twice. We've seen this with a little bit of what we've done so far with our graphing, that it could open up and it could open down, but it could only touch the x-axis once. The vertex could be the x-intercept, and we'd only get one solution in that case. Or possibly it opens up or opens down, but it does not cross the x-axis, which means we don't have any solutions, all right, at all. So we should be prepared that we could have 2, 1, or 0 as we work with our quadratics. All right, so like I said, the good news about today, no new mechanics to teach you, just taking what we already know, using those to go through and do some graphing. All right, so let's go ahead and jump into number 1 here. All right, and what we want to do is graph this quadratic. Notice that it's already set equal to 0 for us. All right, and when it's equal to 0, that's telling us we want to find, all right, this, all right, where it crosses the x-axis right here. All right, so let me just change my pen color here. All right, now the first thing we have to do is identify what form is our quadratic in. Now, in this case, it's in vertex form. Or excuse me, it's not in vertex form, it's in standard form. So what we want to do then is we have to use, right, our little formula, x equals, all right, the opposite of b, all right, divided by 2a to find our vertex. All right, so when I look at this guy, I can see that a is -2. All right, b is -8, and c is -6. So I identified all my values, right? And so I'm just going to go ahead and plug this in into our little formula. So x equals, all right, the opposite of b this time means we're going to get a +8. All right, and then 2 times -2. All right, so that's going to give us 8 divided by -4, which is -2. All right, so that's the x-coordinate of our vertex. So we have half the vertex here, so -2. Now, to get the y value, we have to take that and plug it into our equation. All right, so y would equal to -2, and then -2 squared minus 8 times -2, and then -6. And then once again, just use whatever you have handy. If you have your phone, use your phone. If not, you can use a calculator if you have one. There's lots of stuff that you can download. All right, I'm just going to come right over here. So -2, and we're going to type it just like it looks, right? Okay, parentheses included, exponents included. All right. And let's see what we get here. -6. All right. And so we get that y is equal to 2. Okay, so now we have our vertex, right? So we can start with our vertex here. So our vertex is negative 2, 2, which is right here. Now, once again, all right, we know our a value is negative 2, which means that 3a would be negative 6. All right, so from here, I'm going to go down 2 to the right one, down 2 to the left one, and then down 6 to the right one, and maybe, and down 6 to the left one. All right, let me clean this one up a little bit here. All right, and then now we just want to draw that curve in, and you can already see, all right, based on what I've done, that we're going to get 2 x-intercepts. There's the first one that we just passed through there. All right, and then I'm going to pass through the second one right there. Okay, and so our x-intercepts are going to be negative 3, 0, and we want to write them as points. All right, and we want to write it as 1, negative 1, 0. All right, so there are our 2 solutions. All right, so let's take a look at example 2 here. Maybe, don't go too far. All right, let me see if I can try to get this to go just a little bit here. All right, so there we go. Stop. There we go. All right, so now, all right, once again, the first thing that we have to do if we're going to graph, all right, is we're going to have to figure out, okay, so what form are we in so we know how to graph. Once again, this is still standard form. So if we see an x squared term and an x term, we know that's standard form. All right, and so I can look at this and I know my a value here is going to be negative 1. We know that our b value is going to be negative 2. And then our c value this time is 0. All right, so if we jump into our little formula to find our vertex, we have x equals the opposite of b, so that means we're going to have a positive 2 this time, divided by 2 times a. All right, so that gives us 2 divided by negative 2, which is negative 1. So there's half of our vertex right there, so we get negative 1. All right, now when we think about y, we have to go back and just plug this in. So I have the negative that's sitting out front, and then I want to do negative 1 squared, all right, minus 2 times negative 1 equals, and then once again I'm going to come over here to my calculator. All right, I'm going to have the negative that's sitting out front, and then my parentheses. All right, and then I'm going to have negative 1 squared minus 2 times negative 1, and we get that that is 1. All right, so now our vertex is negative 1, 1. We've already said that a is negative 1, and 3a would be negative 3. All right, so if I start at negative 1, 1, that would be right here. And then notice my a value is down 1 to the right one and down 1 to the left one. So right there we can see what our solutions are. And if I just go ahead and do our next 2 points, 1, 2, 3, right here, 1, 2, 3, right there. See if I can get somewhat close to these 2 points on my way down there. Just keep going. I've already stopped. All right, and then coming this way. Oh, I missed that one by a lot. All right, and then it just wants to keep going. I've stopped. All right, so, all right, now I'll have to go back and clean that up a little bit here. All right, so, but you can see that our solutions are negative 2, 0, and we go through 0, 0. So sometimes it does go through the origin, no big deal. So 0, 0. All right, so now let's look at our final example that we're going to do together today. And I'm going to have you do 3 problems on your own to make sure you're good once my eraser stops moving. All right, so while my eraser's off on its adventure there and didn't erase what I really wanted it to erase there, all right, let me switch my pen here. All right, and we'll go through our last problem together here. Okay, now this one's a little bit simpler because notice what form are we in here? Vertex form. All right, so now that means we can just jump right into the work, right? Because we can see the vertex is negative 2 and positive 3. All right. Positive 2, positive 3. And then we can see that our a value is a positive 3. All right. Try to get a comment in here. There we go. Positive 3. And then 3a would be a 9. 9. It's maybe a 9. It looks like an old decrepit 9, but it's still a 9. All right, got a little hunchback there. It's about to fall over. All right, so negative 2, 3 would be right here. All right, now I'm going to go up 1, 2, 3 to the right one. Up 1, 2, 3 to the left one. I'm not going to be able to go up 9. All right, so I'm just going to take these 2 points here and use them to graph. All right. Oh, man. And then I'm going to turn and go the other way right here. All right, now what you may notice here is that we do not cross the x-axis. So that means we do not have any solutions, right? No x-intercepts, so there are none this time. All right, so once again, kind of be ready for those 3 situations. All right, so now I'm going to set you loose. All right, there's 3 problems left in our notes for today. So I want you to do problems 4, 5, and 6. And then I want you to check your work. Now, once again, there's a couple ways to check your work. You could turn the video back on. You could hear me go through the next 3 problems. You could turn the video off. You could open the note sheets that are worked and complete and check your work that way. The most important thing is that you do the work, you check the work, whichever way you feel most comfortable. So either way, pause the video, turn the video off, do 4, 5, and 6, and I'll check back in with you soon. All right, so let's see how you did. Now, I did all the work for 4, 5, and 6 here, so I'm just going to kind of go through these real quick. Now, this, if you recognize as in vertex form, is much quicker than standard form. Now, you can still do this in standard form, but notice that means b would be 0. All right, but that means my vertex is 0, negative 8. My a value is 2, so I'm going to go up 2 to the right one, up 2 to the left one, and then 3a would be 6. So I'm going to go up 6 to the right one, up 6 to the left one. And you can see, all right, that we get 2 solutions this time. So we get negative 2, 0, and we get 2, 0. All right, now 5, once again, is in vertex form. All right, you can see that the vertex is 6, negative 4. So I'm going to start at 6, negative 4. All right, my a value is 4. So I'm going to go up 4 to the right one, up 4 to the left one. My 3a is 12. You might be able to sneak it in up here, but really it's not needed because we're looking for those solutions. We're looking for those x-intercepts, and we can see that those would be 5, 0, and 7, 0. All right, and then our final problem down here, all right, is in standard form. All right, so you have to go through and do a little bit of work to find the vertex. So a is 2, b is 8, c is 10. All right, so we have to do our opposite of b over 2a. So the opposite of b would be negative 8. 2 times 2 in the denominator. Then negative 8 divided by 4 is negative 2. If we go back and plug that into our equation, you should get a y-coordinate of 2. So our vertex is negative 2, 2. I'm going to go up 2 to the right one, up 2 to the left one. All right. And then, okay, up 6 to the right one, up 6 to the left one. And then just like the earlier example, you can see that it does not cross the x-axis. We don't have any solutions here at all. And so that wraps up our lesson for today. So take a look at, all right, the homework for this. The good news is, once again, it's just really reviewing, and hopefully while we're introducing an idea of what solving is, what solutions are, and how x-intercepts tie into all that, it's really just giving you an opportunity as well to kind of refine, all right, and sharpen those skills in graphing. So we are finished for today. All right, take care of yourselves, take care of each other. Let us know if you have questions. We're there for you for whatever you need. All right, and we will see you soon.